Particularly the most active oil and gas basins you can think of in the United States. They're drilling, mile and a half, almost 2 miles deep to produce these hydrocarbons. And they're generally in hotter basins because you need that heat to turn that oil into gas. And so they're thermally mature basins. And so a lot of times those basins have significant heat that's also being brought to surface. In the Haynesville, for instance, bottom hole temperatures are north of 300 degrees Fahrenheit. For our project we're working on with Cord in North Dakota, their bottom hole temperatures are 290.
Okay.
So right in the power generation zone, and a lot of oil and gas companies view that heat as a nuisance or a safety risk.
Welcome to Geothermal Unleashed, where we're going to explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Vallourec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. And I want to give a special thanks to Think Geoenergy. And I'm super excited today to welcome my guest, Johanna Ostrum, COO of Gradient Geothermal. Big welcome to you. You're sitting in Denver, Colorado right now, and I'm sure it's a little bit colder than it is here in Houston. Why don't we get things kicked off by you telling us a little bit about yourself and your journey into the geothermal space?
Yeah, well, I just want to say, first of all, I'm really honored to be on the podcast. I've listened to your previous episodes and followed your work in the geothermal industry. So very honored to be here. But yeah, so how I found my way to geothermal, I was actually an engineer in the oil and gas space for about 15 years. A geological engineer, so I've always been interested in the subsurface and how to produce oil and gas most effectively and efficiently. And so in 2020, the company that I was working for filed for bankruptcy, and I was like, well, gosh, what do I want to do with my career? And so I started meeting with former colleagues, and I met with Ben Burke. He and I had worked previously together at Noble Energy and had kept in contact. And he said, hey, I've got this idea of taking waste streams, specifically hot water from oil and gas, and figuring out how to, make revenue off of that. And so I said, that sounds a lot like geothermal. And I'd always loved geothermal. So we, started the company in 2020 with this idea of instead of drilling oil or geothermal wells, why don't we use heat that's already being produced from existing oil and gas wells? It kind of gets rid of two big problems with geothermal, which is the drilling risk and the regulatory risk. So we started with an idea and managed to grow it 4.5, almost 5 years later into a company with several projects working across the world. And I'm excited about the momentum for Gradient Geothermal, my company, and also where this career could take me.
Okay, I want to ask some clarifying questions. So,
Yeah.
from oil and gas, when you're producing oil and you have water too, there's heat.
Yeah, so a lot of oil and gas wells, particularly the most active oil and gas basins you can think of in the United States, they're drilling, mile and a half, almost 2 miles deep to produce these hydrocarbons. And they're generally in hotter basins because you need that heat to turn that oil into gas. And so they're thermally mature basins. And so a lot of times those basins have significant heat that's also being brought to surface. In the Haynesville, for instance, bottom hole temperatures are north of 300 degrees Fahrenheit. For our project we're working on with Cord in North Dakota, their bottom hole temperatures are 290.
Okay.
So right in the power generation zone, and a lot of oil and gas companies view that heat as a nuisance or a safety risk. We've talked to operators where they say, oh, the pipe's so hot it burns our operators, so we try and cool it down. So it's very interesting how the oil and gas business views heat versus the geothermal industry.
Okay, so I want to ask some questions that sparked
Yeah.
up based on that. The wells with oil and gas, they're what, like a 6.5 inch? And do you lose a lot of the bottom hole temperature when you're producing to the surface? Because part of in geothermal, you're trying to produce as fast as you can to preserve that heat.
Yeah, so you have the same problems and same issues that you have in the geothermal space, which is the longer it takes to get from bottom hole to surface, the more heat you're going to lose. But just like in geothermal industry, in the oil and gas industry, they want to produce that fluid as quickly as possible as well, because that's revenue. It's more oil and gas you can get out of the ground. So there is some temperature loss as it comes up to the surface, and frequently it's, there's hydrocarbons being produced along
Right.
with the hot water, and oil and gas don't hold the thermal energy as well as water does. So you have some significant heat loss to surface. It depends on how the operator's running and their flow rate. So you can get anywhere from 25 degrees to 50 degrees to more than that heat loss as it comes to surface.
Okay, will you explain high level to me how your system works at the surface, how you're actually extracting the heat?
Yeah, so we use organic Rankine cycle technology, which is very similar, well, nearly identical to what you'll see at a large geothermal power plant, except ours are much smaller. So the size we have in operation right now is a 75 kilowatt system. So they're smaller, they're modular. We have them on trailers or skids, so they're movable, and they also can be put in series or in parallel. So if you have a lot more fluid flow, you can put many of these together and make more power than 75 kilowatts on location.
And I imagine you need to put these right next to the wellhead because you'll have more thermal loss. You couldn't put it like at a gathering station because you would have cooled down by the time you get there.
Yeah, it's all a balance, right? It's finding the
Okay.
heat. So, and the volume. So we'd like to be as close to the wellhead as possible, but sometimes that doesn't work because we need more flow rate. So the first two installations we've had has actually been at a central processing facility because it doesn't lose. Surprisingly, on surface, there's not a lot of heat loss because it moves pretty quickly from the wellhead to the surface facilities. So frequently we're behind the separator, and the separator is a piece of equipment that, like its name would suggest, it separates the oil, gas, and water based on gravity. And we take the water stream after the separator and produce electricity and provide cooling at that location.
Interesting. That's very good. So on a given well, um, or I guess let's look at the project base, not by well. What is the type of megawatts that you can produce?
Yeah, of course, it's highly dependent on temperature and flow rate, but our first pilot operation was out at Blackburn, Nevada, and that's where we took this idea of hot water can produce power at an oil and gas site and actually built the equipment and ran it for about a year and a half. And so our system on a gross basis is 75 kilowatt. It's net less than that, of course, because you've got parasitic load from pumps that move fluid around and some friction losses. So when temperatures were and conditions were right, we were making 35 to 40 kilowatts at that location consistently in the cold winter months. Um, and that was with like 2,600 barrels of fluid per day at about 200 degrees Fahrenheit. So the higher the flow rate and the higher the temperature, we can generate more electricity. But it's kilowatts at multiple locations that lead into megawatts.
Okay, so you are gathering all of that's what's being produced. What are you doing with the electricity? Is it used for infill power or what is it used for?
Yeah, that's really up to our customers. So we provide a piece of power generation equipment and we provide modeling of what the power it can produce. And if they need cooling on location to meet pipeline specifications, we'll also provide cooling. And so we model that and then they use the power generally on site. We are looking at a location in Texas where they don't need much power. So we will be net metering or selling to the grid. It's a lot like rooftop solar for residential in that when you need power, you
Yeah,
can use it, but if you don't need power, you sell to the grid. So
got it.
yeah, it's quite similar in that way.
And then you don't have to do it just on oil and gas. If you have natural gas wells, this could also be
Yep, absolutely. So we take all three phases, oil, gas, and water, through our heat exchanger system, our HXC sled, and that's our proprietary piece of equipment. Of course, we prefer hot water. It has the best thermal conductivity, but if we have a lot of hot gas, that works as well too. And so we are working with a client in the Haynesville where we'll be mostly gas with some water initially at production, but a lot of hot gas. And so we're able to transfer that to our ORC to generate electricity.
So is this going to be on any new drills that are oil and gas where you could go in and design this? Or do you specifically look at old wells that are producing more water? Is that when you come in?
We can do both, really. And again, we're just searching for temperature and flow rate. And a lot of times, most of that comes from new wells because they have the most reservoir pressure, and they're the newest wells. And so, our application that we have up in North Dakota, that's a brand new Bakken Three Forks pad. So, there's a bunch of wells drilled to the Bakken. And in the project that we have upcoming in Louisiana, that will be new drill wells as well. So it really depends on where we can find that heat and flow rate.
Wow. So big play in Haynesville because we have really hot temperatures. Eagleford, I imagine, is another
Yes,
area
that's
you
a
guys.
that's a good opportunity we're looking at. There are several basins in Texas that could be really great. The thing you're balancing with Texas is you have a higher ambient air temperature, and so your differential, which is really what you use to generate that electricity, is not as high as what you have on a cold day in North Dakota, for instance.
Right.
So there are some advantages as being in Texas, and some disadvantages.
Okay. And so the business model for Gradient Geothermal is your customers are oil and gas companies, and you're working alongside them. You would never
Yeah,
take old wells and then own the wells and produce electricity from those wells, would you?
Yeah, at present, no, but we evaluate opportunities where we can own and operate ourselves, but it has to be the right asset. But that's something we're looking at expanding
Okay.
into in 2025. We're also working on a project in Colorado with Chevron where they have existing idle oil wells that some of them were drilled in the 1960s, up until most recently a few years ago. We're looking at turning some of those wells back online and producing power as well as providing heat to the community nearby for
Okay.
heating sidewalks, or there's a school nearby. We're looking if we can help them with some of their heating bills. So we're really excited about this cascading uses of geothermal energy beyond just power generation, but how do we tie this hot water resource into the communities that we live and work in?
That's pretty cool. Okay, I want to ask more questions about that, but I have another I guess technical type of question. If you take some of these old wells, maybe they've been producing for a while, do you see the temperature drop over time though?
What we see is the reservoir stays the same temperature. We see a temperature drop at surface because flow rate
Okay.
decreases.
Okay.
Yeah, so the reservoir pressure decreases over time, therefore you have less flow to surface or less volume. And so you do see a decrease, though it's not because the actual reservoir is cooling off. It's
Yeah.
because it's taking longer to get from the reservoir up to surface to our equipment.
Okay, so it's different than when you're looking at conventional geothermal or EGS type of geothermal where you're pumping a lot of water and you're cooling the reservoir down. Um, you're producing fluids that have been baking in the reservoir and you're capturing.
Yes.
Okay, okay,
Yeah, exactly. There are water, and in the oil and gas industry, we consider those water flood
okay, yeah,
operations where they produce water and oil, they skim off the oil and then re-inject the water to and then back into the reservoir to push those oil particles up to the wellbore again. So it
sure.
just circles around and you're trying to flood the reservoir to push oil. So we are also looking at opportunities where we can use our equipment at water flood locations. But again, usually these are existing large oil fields that have been producing for a long time, and us skimming off, a BTU or two is not going to cool the reservoir down. So we don't have the same risk of cooling a reservoir like you would in conventional. And a lot of times, particularly in the unconventional reservoirs, like in North Dakota or in Texas, they produce that water and then they ship it or pipe it to a production well miles and miles away that might be in another formation. So you won't cool off the reservoir because of that.
Wow. This must be a massive market.
We're excited about the market potential, yes. I mean, not
Yeah,
every oil and gas well is hot enough, and you
okay.
have those constraints of flow rate, but it's amazing the amount of thermal energy right now that's being produced that's just dissipating into the atmosphere or purposely being cooled they pay for fluid chillers to cool
Yeah.
the produced fluid because it's too hot. And so, yeah, there's an
And then when
amazing.
that happens, you have paraffin that comes out, right?
Yeah, so they have to be careful with paraffin dropping out, and they can treat that with chemicals or, it depends on how much they cool it, depending on the
Yeah.
API gravity of the oil. Yes, there's all sorts of things you can
Interesting.
encounter in the oil field.
But in North Dakota alone, I mean, you've got thousands and thousands of wells. So
Yes, yes, yep.
that's,
We're excited about the potential.
yeah. Okay, so let's go back to what you're doing in Colorado. So this is the project that's in Pierce, correct? There's a
Yes.
recent announcement that I saw that came out about this. I think it was this week that talked a little bit about how you guys are doing a feasibility study for, I guess it's for Chevron. It did mention Chevron in the article. So can you share a little bit about like what do you do when you're doing the feasibility? What are the things that you need to look at to evaluate if that is a good project?
Yeah, so we actually were awarded that grant in October of this year, and it was
Okay.
actually well, it was funded through the Colorado Energy Office. So we received $100,000 to perform a feasibility study in Colorado in a small town called Pierce, Colorado, which happens to sit right on top of an oil field called Pierce Oil Field. It was originally drilled by Chevron, like I mentioned, in the 1950s and 60s, passed through many different operators, and now it's once again owned by Chevron. And we're also working with a group of thermal energy network experts that design the Colorado Mesa University's geo exchange system. So they're helping us design the system as well. But ultimately, the feasibility study, the goal here is to use existing oil wells in the town that have been shut in, that have produced for 50, 60 years, and seeing if we can turn them back on safely, with a thorough site conditions overview to understand what it would cost, if there are any environmental impacts or any, just understanding the system, and then looking at what would it take to produce power, and then after power generation, what would a thermal energy network system look like? What would it cost? And do we have potential customers in the town, whether that be the city or individual residents or the school district in the town of Pierce?
Now, if you have to go in and do workover on these wells, does it become economically unfeasible? If
Yeah, great question. That is part of the feasibility study. So, in all transparency, we had done quite a bit of work on this prior to the grant
okay.
application with Chevron, we had been looking at this field actually, honestly, since the inception of the company in 2020, because we were aware of this field. We had folks reach out to us and say, hey, this would be a great candidate for geothermal energy production. They're drilled to, one of those reservoirs that have a water flood, and that a lot of water has moved through that system, skimming off 1% oil. Certainly at the end of the life of the oil field. So it really just moved a lot of hot water around. So the wells, as we understand it from state information and from Chevron, look to have great mechanical integrity. So we are not overly concerned about having expensive workover costs. Also, the central facility has been somewhat reclaimed, and there was a historical spill, but they're cleaning that up. So we have a lot of information about the status of things, and right now it doesn't seem like those costs are going to be very large. However, when you do start moving a lot of fluid around, there are pumping costs and pumping electricity that will be needed to move all that fluid around. And so part of that is understanding how much can we cover with our geothermal power production, or what does that really look like when you think about the economics of the whole system? Because ultimately, the goal would be to come up with a project that's economic, both for us and for the
Right.
town and for Chevron. And we are able to reuse and repurpose oil wells within a town and potentially, have new jobs and new economic impacts for the town. So it can be a real exciting project, but the feasibility study is really to figure it out. And then if we figure out here, we think we can duplicate it across other small towns and oil fields across the United States and potentially the world.
It's pretty cool. I'm curious, like these wells are not like your unconventional wells that are horizontal wells with lots of fractures. These are probably vertical wells. I'm sure they probably have bigger casing sizes than what you
Yes,
have
yeah.
now. So maybe they are um like better suited for what you're going after to get the higher flow rates.
Yeah, I mean, They're 7-inch casing wells, most of
Okay.
them. So they were designed to move a lot of fluid. The original engineers and geologists and operations folks that drilled these wells knew they had to move a lot of fluid to get the oil out of the ground. And so they're designed to move a lot of fluid. So that helps us because that's ultimately what we want to do.
Yeah.
Yes, they are drilled vertically. They're drilled to a very permeous and permeable
Hmm.
and porous um, zone called the Lion Sandstone. And
Hmm.
so it's really a great setup for our testing of our technology
Yeah.
and thermal energy networks.
Interesting. But it's a different story in the Haynesville. You'll be dealing with,
Yeah.
I would assume, unconventional
Hmm.
horizontal wells.
Yep.
Very interesting. And I liked the part where you're already talking about creating jobs. So is that part of your feasibility study about what the impact of doing a project like this could be on the community?
Not officially as outlined by the grant, but that's something that is important for me because I came from the oil and gas industry. I want to build jobs in these communities and employ oil and gas people to do these jobs. So that is something that we will look at as part of the economic impacts. And we have a portion of our project is a community impact study and a benefits study. And so we want to reach out to community members and figure out, I mean, ultimately, it would be great if we could replace their current natural gas system with something that's more efficient and cheaper and could provide more stable thermal energy to the town. And we want that to be if not cheaper, at least the same price. So that's also part of it. We don't want to create a burden on the community or else it doesn't make sense for
Yeah.
anybody.
Okay. All right. I have to, this is a random question. Will there be a new term for this type of geothermal? What do we call this?
Let's design it today because we don't have an answer for that. I had actually reached out when I was applying for the grant, when we were applying for the grant, I
Yeah.
reached out to Amanda Kolker at the National Renewable
Yeah.
Energy Lab. And I said, Amanda, what do I call this? Because it's not really a thermal energy network. It's not a geo exchange system because we're incorporating oil and gas. And she's like, I don't know. And we don't have a name for it. So maybe you guys should come up with something. So I'll take all the
Okay,
ideas.
I'll come up with some ideas and send them your way.
Yeah,
You
I
get, I
love it.
mean, come on, you've got to coin this term
I
and take credit for it.
I have many skills, not, but I can't name anything. Luckily, my kids have names, but that's I'm
You're
not good
right.
at naming things. Yeah.
Right. Well, it's gonna come.
Yeah. We'll
Someone will
see.
name this. That's
Yeah.
super. I'm just, I didn't realize that you guys were doing this. I knew I've heard you speak before. By the way, you're a fabulous speaker. You're always my
Thank you.
favorite when I've had the opportunity to hear you. But I think I just needed to ask some more questions to fully grasp
I
what you
love
guys
it. I
are
love
doing.
talking about it. So ask me more
Yeah.
questions.
Okay, so now let's turn to the North Dakota. So that was another project that's in the news. It's publicly out there that you guys are working with Cord Energy. Can you talk a little bit about what you're doing, and does that look different than what you're doing in Colorado?
Yeah, so we're very excited about this opportunity that we have with Cord Energy. Again, we actually received some grant funding from the North Dakota Industrial Commission to pay half of the cost for this project. Originally, we were working with Enerplus, and they were acquired by Cord earlier this year. So we've been working with Cord Energy. But really, the goal up for them in North Dakota is they produce a lot of hot oil, gas, and water. And all of it is too hot for their poly pipe or their plastic pipelines. So those HDPE pipes melt above 130 degrees Fahrenheit. And they're producing fluids, at IP, they could be, or initial production, they could be 190, 200 degrees Fahrenheit. So they have large oil, gas, and water chillers that they use, multiple of them on location to cool so they don't melt their pipeline. It's a lot easier and cheaper to install plastic pipe than steel pipe. So ultimately, the economics work out for the oil and gas operator to pay for these chillers. And then eventually, as the production drops off, they can remove them. And long term, it's cheap to have these plastic pipes. So in this case, we're replacing a fluid chiller and generating electricity for them. And this is a pilot project really to prove the efficacy of this. We have data from our Nevada project showing that we can cool and produce electricity, but it's really proving it to, operators in larger basins. So we started with cord a few months ago, have been able to provide, I think, 98% uptime on our cooling. Power generation has been challenged because the prediction of how hot these wells were, they ended up being about 20 or 30 degrees cooler than what we had initially expected. And so we were able to generate some power, but not as much as we'd like. So we're looking at potentially moving our system to another pad and moving closer to the wellhead, which, as you mentioned at the top of this, is that's where the heat is. So if we can move as close as we can to that. So we're looking at designing a three-phase heat exchanger system that we can, again, provide cooling, but really get to measurable power production for them.
Super cool. Do you think there'll be more opportunities with, I guess, cord outside of this current project? Do you think this would be something that they would expand to other locations? I don't know where all of their wells are around the US.
Yeah, so they're a large operator in the Williston, but they also operate, I believe, in Texas as well. They're one of those companies that have acquired a bunch of other companies over time.
Mhm.
Um, and so but they've acquired quite a bit in North Dakota, and that's kind of been our main focus. But yes, the goal is to expand. They use hundreds of chillers on their oil and gas site. So in some ways, you can think that we're a much more efficient chiller because we don't use as much electricity, and frequently we make our own. So it depends on how you want to talk about it with our customer, but really much more efficient chiller or generator that works off of hot water. So we are looking to expand with them and are looking forward to next year.
Yeah. Are there any other projects that you're working on that you can talk about?
Well, we'll continue to move on with our project in Nevada. So that's actually part of a DOE funded project to generate 1 megawatt of geothermal electricity at existing oil field. We're through phase one of that project, which was a feasibility study, and we're moving into phase two, which is operations. And so we're excited about the potential of this field out in Nevada. It's a very hot resource, and they don't have to use downhole submersible pumps. They flow artesian, which for a geothermal field is great because you don't have that parasitic power loss. So we're looking to expand at that location coming in 2025 as well.
Interesting. Are there other locations that you've got no use of ESPs?
Those are kind of a needle in
Hidden
a
gem?
haystack. Those are great opportunities. But we're also working on some international projects that we'll announce in 2025. We're a small company. We certainly didn't look to, have international project at this stage, but there's just great opportunity. And so we've been looking at expanding and providing our services outside the United States.
Did that just happen organically where you were approached, or did you just start looking?
Actually, both cases we were approached and they
Okay.
reached out to us. So our business development is luckily have not been a heavy lift. We've gotten a lot of contacts through, pretty much everybody at the company came from oil and gas, and so we know a
Yeah.
lot of people. And when we talk about what we do, they're usually like, "Oh, I'd really like to learn more." And there's usually opportunities that fall out of that. So luckily, a lot of the projects have really come to us. I'm sure as we grow, we'll have to work a little harder to get our story out there. But so far, we've got more than enough work.
Yeah. Fascinating. Okay. This is so cool because it's like
Yeah.
a new side of geothermal that I wasn't very well versed on. Okay. So, let's talk about North Dakota and geothermal in general. Do you think we're going to see outside of, using oil and gas and trying to skim off the heat from oil and gas wells? Do you think we're going to see growth of geothermal for power generation or direct use in North Dakota?
I certainly hope so. If you look at what Deep Earth Energy has been doing right across the border in Canada, they're technically in the Williston Basin. They're just right across the border. So it's using that same sort of oil and gas technology, workforce pipelines to drill in an oil and gas basin. So I think North Dakota, much like many other states, are trying to figure out what's going to happen when AI really takes off, when this power hungry electrification of everything happens, everybody's going to need more power. And so I think the utilities are trying to figure out how to meet the growing demand. And geothermal is really attractive and can work in a lot of different places. It's what we're seeing with, other startups like ourselves and, some of the existing incumbents. So I'm really bullish about the opportunity for geothermal energy in states that you haven't seen them before. And I think North Dakota is a great candidate. They love energy. They're an energy producing
Right.
state and they have wind and solar and are looking at other opportunities there as well.
Yeah. Okay. Aside from what you're doing, what are other trends or technologies in the geothermal space that are catching your eye or exciting you?
Yeah, I'm a big fan of all the innovation that's happening in geothermal. It's definitely an upswing in the industry, and I see really good crossover from oil and gas technology into geothermal and new ideas coming in. And so I'm excited about that. I'm also, I have a special place in my heart for thermal energy networks and direct use stuff, and that really hasn't taken off in the United States, and I'd like to see that. So though it's not, I would say, the most innovative, because this idea has been around since forever, since humans have been around using hot water for bathing and things like that.
Yeah.
I think the US really thinking about how to use that strategically when energy isn't so cheap, because there's so many people that need energy. And, we've talked about data centers in the past, but energy is not going to be as cheap in the future. And using hot water as a resource is just a really smart way to help decarbonize the built environment.
Yeah, I agree with you. I think the tens of thermal energy networks and direct use is fascinating. I actually just had a conversation with a Jay Egg.
Mm,
He was on my podcast, and I was just blown away that, he kind of told me the scope of some of the projects that he's worked on. And he was mentioning that in Florida, he's worked on over 3,000 geothermal projects, which blew my mind because I didn't know that Florida was already had that many geothermal projects.
yeah, I didn't know that either. That's
Yeah,
impressive.
yeah, it is. Okay. So, let's see. Colorado, there's a lot of activity happening, and I'm sure you're very plugged into the geothermal space. Can you just highlight some of the projects that you see happening in Colorado in geothermal?
Yeah, I would not call myself an expert of all the things, but I think I live in Colorado, have lived in Colorado since I graduated college pretty much. So I have a soft spot in my heart for the state and hope that geothermal can take off. There has not been a single kilowatt generated from a geothermal project in Colorado yet, but I know that there was funding doled out through the last grant round from the Colorado Energy Office for some projects looking to generate power. So I think some of the struggles with some of those projects is community outreach and getting communities interested and excited, because the oil and gas industry has been active in Colorado for many years, and there is hesitancy by some of the existing folks that live nearby because they're scared of fracking, they're scared of oil rigs and the traffic that come with it, and a lot of their fears are totally valid. Not all of them, but a lot of them are. And I think that I really am concerned about geothermal industry's growth and making sure that we bring communities along with us as we develop, because geothermal is luckily supported bipartisanly, and bipartisanly, that's not a word, but has bipartisan support. And so I want to see geothermal development, but I want it to do it the right way. But there's also some thermal energy networks projects that are coming to Colorado, including ours, but some of them in the mountain communities like Aspen and Steamboat and Vail. So it'll be exciting to see those projects take off as well.
Interesting. Okay. Do you get involved with any of the involved communities and trying to educate? Or do you guys not get that involved?
So part of our feasibility study with the town of Pierce, there's a community outreach portion of that,
Okay.
and I'm just building the plan for that. I've met with the board of trustees on several occasions to talk about the project. It's a pretty small town. There's about 1,000 people there. So it's a different type of outreach than you would do, say, in a major metropolitan area with more avenues for sharing information. But in a broad sense, I don't do a lot at the state level, but it is a passion of mine because I was in the oil and gas space and did a lot of the regulatory work for a time. And so if you don't have community support, you're not getting a project over the line. So it's just so important that we bring communities with us as we look to develop.
All right, let's just stay. We have a few minutes left, and I just want to get your feel for what it's been like joining the geothermal community coming from oil and gas. What have you experienced? How are you involved? Um, what can you speak to on that?
Yeah. I have tried to be as involved as possible. I think it's great. I'm inspired by the people that work in geothermal, um, and the people that I've met have truly care about uplifting the industry and having us all learn from each other. And you don't necessarily see that in oil and gas. There's a lot of camaraderie that I didn't experience, I would say, in oil and gas. So that's inspiring to me. I've been on some volunteer boards at Geothermal Rising, the policy committee, as well as um, it was the DEI committee, but we've renamed, and I don't recall our new name. But I've been involved with that as well. But yeah, I try to get involved as much as I can. Everyone's so friendly, so it's been quite
Oh,
easy to get to know folks.
I was just having this conversation just about coming in from, a different industry into the geothermal space. Everyone is so kind, so humble, so welcoming, so ready to collaborate. It's a great community to be a part of,
Yeah, I mean, it's an honor, really. It's just such cool stuff everyone's working on.
It is. And everybody has their own take. Everybody's approaching geothermal. I mean, every time I talk to somebody just like you, it's like, wow, you guys are doing something so different. And it's just so innovative, trying to capture heat from the earth, because there's so many different ways that you can do it.
Yeah.
Okay, I want to ask one last concluding question. So, what would you share? What would be your piece of advice? No, what can you, okay, sorry, let me ask this better. Can you share a piece of advice that has guided you through your career?
Oh gosh. So I was recently speaking to a friend who was trying to evaluate if he wanted to take this new role. And it was a little bit more pay, but he was worried about how much time it would take and whether he was in the nonprofit space and wanted to go back into oil and gas. And so it was funny as I was counseling him about, what would this look like for you? Of course, ultimately it's his decision, but my tendency is always to say yes because you never know how awesome it could be. And if it's not great, you can always move on and find something. But I think if you're afraid to say yes, you really miss out on a lot of opportunities. And so, you don't need to go too wild and overboard with it. But I think if there's a good opportunity in front of you, I mean, what's holding you back? You should say yes, and just see where it takes you. And if it's not the right path, you can course correct. But I think really being open to change and willing to change is a skill. And I think it really helps you have a broader life.
I love that. I resonate with that.
Yeah.
Well, I want to thank you so much for joining me today. I've learned a tremendous amount, lots of valuable information, and I want to thank all of the listeners for joining us on this episode of Geothermal Unleashed. I hope today's discussion has sparked new insights and deepened your understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.